Hey everyone, welcome to today's talk on building enterprise-ready CI/CD pipelines using Agentic AI. My name is Chinmay Gaikwad, and I'm responsible for the technical marketing of all of the AI products at Harness. Previously, I've worked for companies in the DevOps, Kubernetes, AppSec, and observability spaces. So let's get into the topic. The agenda for today looks very simple. It's the what's and whys of enterprise readiness, the role of Agentic AI and knowledge graph, and last but not the least, one of the most important topics of governance. Let's start with enterprise readiness. Before we get into what an enterprise ready pipeline looks like, let's take a broader view of the problems in the CI/CD space or the DevOps space. So software delivery workflows today are very manual and involve a lot of toil, which means that a lot of companies still use homegrown scripts and point solutions to manage these pipelines. And because of this, the velocity at which the customer gets product updates or feature updates goes down by quite a bit. The efficiency of the engineering team, the security of the code being delivered to the customers, as well as the resiliency go down as well. With AI-generated code, this problem is multiplied or it grows exponentially. As you can see, the bottleneck is still the software delivery pipeline, which means that testing, securing, deploying, and optimizing need to expand to match the AI-generated code. We've seen a lot of organizations using AI prototypes to figure out how to use AI to expand their software delivery pipelines. AI prototypes take less time to build, are used to solve the initial capacity problem, and they stop at prompt engineering. However, with enterprise AI, you need a robust architecture. You need something that demands consistency and reliability, and you also need something that masters context engineering. We'll get into what is the difference between prompt engineering and context engineering a bit later in the session. But because of these differences, majority of the prototypes fail to scale at enterprise level. So the need for enterprise readiness basically comes from the fact that almost 80% of the SDLC failures don't happen during code generation, they happen after the code is written. The tool sprawl doesn't help this problem. It basically amplifies it. So with tool sprawl, you have a lot of unshared context, which basically means that you create fragile pipelines, which basically means that code is not being delivered to the customers in a secure and reliable way. Manual policy enforcement is another blocker to this, which basically means that you have a lot of bottlenecks in the governance and security aspect of things. All of this basically means that teams are stuck balancing between speed and safety. So enterprise pipelines need to solve the velocity and the control problem simultaneously, and which is where agentic AI can be really effective. Let's define what an enterprise-ready pipeline means. Here is a simple layout of a pipeline. I know enterprise pipelines can get really complex, but developer commits a code into code repository. The code is built, tested, and deployed. So that's like a very simple pipeline. What makes this pipeline enterprise ready is it is scalable, it is secure, and it is compliant. What do these things mean though? So by scalable, we mean that the pipeline should be able to support multiple environments through natural language. The pipeline should be able to automatically figure out resource requirements based on workload patterns. It should be able to provision infrastructure based on deployment demands. And it should also do intelligent caching and artifact management across different teams. From a security perspective, there should be real-time vulnerability scanning, so SAST and DAST scanning across the board. And this is done during code generation, during build, at each stage of SDLC. Supply chain integrity is becoming really critical these days, so tracking the provenance of every artifact and dependency has become extremely important. And secret management, basically rotating the secrets, as well as giving the least privileged model access, has also become very important. On the compliance side of things, the compliance should be a default, not a reactive measure. Audit trails for everything that is generated, right from code to builds to artifacts, should be a mandated thing. And there should be regulatory requirement mapping such as HIPAA or SOC 2. And finally, there should be documentation for each and everything that's being generated. So let's look at how Agentic AI helps you to achieve enterprise-ready pipelines with the help of knowledge graphs. The role of Agentic AI basically is to make sure that there is autonomous problem solving So the agents can actually be proactive in perceiving failures and reasoning the root cause, etc. There should be specialized agents, for example, DevOps agent, SRE agent, across the board. And it should not be orchestrated by humans. It should be orchestrated by an agentic AI. There should also be a continuous learning pattern. So AI is really great at learning about different patterns. And then that feedback loop should be fed back into it so that next time, whenever it comes across a similar pattern, it can action accordingly. And policy as an intent should be fundamental for agentic AI, which basically means that AI should understand what are the enterprise's policies and best practices and implement them. Let's look at context engineering versus prompt engineering. Andre Karpati said +1 for context engineering versus prompt engineering. And I completely agree with that. And let's see why. Prompt engineering is basically dependent on the user's skill and specificity, whereas context engineering is actually dependent on your system's knowledge. So your enterprise's policies, templates, and infrastructure. So it's way more comprehensive than prompt engineering. Let's look at an example. In enterprise CICD, when the user says, build me a pipeline, the AI which has access to rich context, will figure out your governance, your templates, your infrastructure, and your team standards to build pipelines that are secure and compliant. This is by design and not by luck. So that's why this reframes why knowledge graph and strong governance matters. And your context essentially makes AI really reliable at an enterprise scale. So to put this in a diagrammatic view, whenever a user prompt comes into AI, AI uses context which it has access to create enterprise-ready pipelines that are scalable, secure, and compliant. So that brings the entire picture that we discussed together. Let's look at how exactly we build knowledge graphs. First of all, let's get into what a RAG and a knowledge graph is. So knowledge graph is basically structured data that is organized as nodes and the relationships between those nodes. We'll look at an example a bit later. RAG essentially is unstructured data from external sources. So if you have like playbooks in Google Docs or Word, that would be a good example of unstructured content. And then the hybrid approach is making these knowledge graphs rich using RAG as an input to these knowledge graphs. So for DevOps, in a DevOps world, everything is relationship based. So for example, let's say an e-commerce business has hundreds of microservices. And let's say if I update service A, I need to figure out which downstream services are affected. And that basically, I need to figure out the relationship between different services and basically points to creating a rich knowledge graph. What we recommend for DevOps use cases is using a hybrid approach, which is a rich knowledge graph, which is ingested with RAG. So let's see how we can build such a knowledge graph. So first you need to extract entities such as services, users, and incidents. Then you need to enrich with metadata. So you have to figure out the owners, the versions, and the policies. Then you need to connect these together. So you have a relationship between who owns what and what depends on what. And then finally expose this to the AI agent so that they can make use of this data. Fellow engineers said this pretty accurately. If context is the new code, knowledge graph is its compiler. I really love that quote. So again, in a diagrammatic way, this is this very simplistic view of knowledge graph. You have entities, events, and third-party data, and they are all connected. So you know what the relationship between different entities, events, and third-party data is. Let's talk about governance now. For governance, we need to figure out who, what, how, and why. Basically, who has access to what. And RBAC is a great example of figuring that out or giving access to specific users. What access does AI have to your data? So what data is being used to train, where the data flows from, etc. These days, a lot of LLMs have zero data retention policies, so your data is not used for training. This is a great example of data and privacy guardrails. The how focuses on policy enforcement and guardrails. So essentially how AI behaves, can set guardrails so that the AI doesn't break those guardrails and operates within a safe environment. And the why is basically auditability. So for everything that AI does, you need to audit it, you need to tag it. So for example, if an AI creates a pipeline, you should tag it as AI generated pipeline so that your compliance team can figure out what was AI generated and what was not AI generated. So again, a different code this time. Context is the new code and governance in its new runtime. Let's talk about RBAC for a second. With RBAC, it's very interesting. The question always is, should AI have its own RBAC, or is there a different mechanism for RBAC for AI? Our view on this is that the AI is an extension of the user. So whatever RBAC is assigned to a user should be applicable to the AI as well. An example is given here. Example, if a user cannot deploy to production, then the AI should not be able to deploy to production. Another example is modifying policies. Only admins in organizations are supposed to modify policies. And as far as AI is concerned, the admin AI can modify policies, not a user. So essentially, AI becomes an extension of the user, and thus the RBAC is also tied in that way. So the enterprise adoption framework that we have seen a lot of customers use and be successful is there is a prompt, AI generates a pipeline, the audit trail is updated, the user saves or executes the pipeline. Then in this case, the RBAC is checked, on save, the policies kick in, and depending on the RBAC permissions and the policies, the pipeline is either executed or it fails, and then a real-time feedback is given back to the user so that they can modify the pipeline or involve the necessary people to make sure that this pipeline executes. This is a very simplistic framework that we have seen a lot of our customers use and scale their AI. Let's look at an example of how we have implemented enterprise-ready CI/CD pipeline creation. Just to give you a brief overview of Harness platform for those unfamiliar with it. So we have a lot of products, around 18 products, and everything is powered by Harness AI. So essentially, we make sure that you create CI/CD policies or infrastructure using Harness AI, and they are enterprise ready. So what we do is, whenever a user gives a prompt, a unified agent takes that prompt and divides it into different specific agents that are specialized in specific domains. For example, the DevOps agent can take care of CI/CD pipelines, the release agent can take care of feature management work, the reliability agent can take care of chaos engineering, etc. And then once the agent takes care of that work, the output of this is either pull requests or pipelines or dashboards. But what powers all of this is the context. The context basically is, as you can see from top down, knowledge graph. So whatever the knowledge graph is created based on Harness actions, so building, deploying, etc. And as well as external data. So if you have a Jira ticket somewhere, so getting context from that Jira ticket, for example. The other layer of context is essentially your enterprise rules and policies. This is the governance aspect of things that we discussed. So this creates a guardrails for the AI to take action on. And memory is also critically important because then the user doesn't have to restart from scratch every time they log in. There is memory and there is context saved in that memory that the user can reuse for the AI to be more effective. So that's a very practical example of how we have implemented all the things we discussed in this talk today. And I leave you with this practical example. I hope you had a good understanding of how to create CI/CD pipelines using Agentic AI that are enterprise ready and can be done at scale. Again, thank you for listening to this talk. If you have any questions, please feel free to reach out to me on LinkedIn. My LinkedIn is shown here. And again, have a great day. Thank you.